Okay, and we're back with the last half of it. All of the members of a science club enjoy astronomy. So all of the science club enjoys astronomy. Okay, some of the members also enjoy biology, and other members enjoy physics. Irene is a member. Using deductive reasoning, what can we conclude? Okay, we can conclude that Irene enjoys astronomy because it says all members enjoy astronomy. Okay, she might like biology or she might like physics, but we don't know which one. We can't conclude that. Janice drew a parallelogram. Which is true about the consecutive angles of a parallelogram? If y'all will remember, parallelogram consecutive angles always add up to be 180 degrees. If they're 180 degrees, that makes them supplementary. Given, okay, and all of these answers, it talks about angle CBD, okay? So that's this angle right here. CBD is congruent to ACB. This one's saying that these two are congruent. Nope, that's not true. Because we know that this is an exterior angle and that the exterior angle is greater than the interior angles. CBD is complementary to ABC. That's this angle. They're not complementary, they're supplementary. They equal 180 degrees, so that doesn't work. CBD is the sum of BAC and ACB. Okay, that means you add those two up, you get your exterior angle, which is true. Which represents a diagonal. A diagonal is going to go from one corner to the next, not on one plane. So we have like AG, we have D to whatever that point is on the other side. We have B to F, we have E to C. Okay, all of those go inside the figure, and the only one that we have that's mentioned here is AG. Alright, next one. Consider the statement WX equals YZ, then YZ equals WX. That's the symmetric property, okay? All we're doing is saying the same statement, we're just flipping it. Alright, two lines intersect. This is going to be congruent to this one because they are vertical angles, which means that angle 1 is 50 degrees. Alyssa has the following proof. E is the midpoint of AC, which means AE equals EC. AB is parallel to DC, that's given. AE equals EC, that's definition midpoint. AEB equals AEB equals CED. Those are vertical angles, are congruent. Okay, so now EAB equals ECD, this one. Those two, as you know, okay, we've got parallel lines, and then we've got these two angles, which are alternate interior. Okay, so alternate interior. Alright, so now why are our triangles the same? Well, we have an angle, a side, and an angle. An angle, a side, angle. So this would be angle, side, angle. Making that C. Alright. Blah, 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 blah. Parallelogram AB has length of x plus 3, and an adjacent side has x plus 2. Which statement explains why the perimeter? Well, adjacent sides have to be congruent. So this has to be x plus 3, and this one has to be x plus 2. This one says adjacent sides are not congruent, so that doesn't work. Adjacent sides are not parallel. We know that that's false because adjacent sides have to be parallel in a parallelogram. Opposite, adjacent sides. Adjacent sides can be congruent because it can be a square, but they are not parallel. That is actually true. But that doesn't explain the perimeter. Opposite sides of a parallelogram are congruent. This side equals this one equals this one. That is true. That's what we're actually looking for. All right. Which statement is a contrapositive? That means if you flip the hypothesis and the conclusion and negate them both. So quadrilateral ABCD has at least one pair of parallel sides. That's got to be false. Quadrilateral ABCD has at least one pair. Okay, that's stating it the same way, so that's false. Quadrilateral ABCD has no pairs. Okay, this says it has at least one pair. This says it has no pairs. Okay, that's negating it. That's true. And then it also has to negate the hypothesis. Quadrilateral ABCD is a parallelogram. So it says it's got to say it's not a parallelogram. ABCD is not a parallelogram, which makes that the answer. Approximate measure for GJK. Okay, we know it's got to be more than 90 because we've got at least 90 right here, and which means it can't be that. Let's see. 5 degrees is going to be very, very small. 95 would be something like right up in here. Okay, so we want bigger than 95. I would say probably about 120 because that's about a 30-degree angle. And you'll just have to learn your angles and what they look like. This is a 45-degree angle, so this is smaller than a 45-degree angle, and you can tell by looking at them. So, okay, the statement shown below is valid. The converse, okay, the converse. Let's see. If Michelle is in the math club, then she participates. If Michelle participates, then she is in the math club. Okay, so it's going to be one of the first two. If she participates in competitions, then she is in the math club. Well, she could be in the social studies club and still participate, or she could just participate without being in the math club. So, okay, we want it to say if she participates, then she is in the math club. Okay, that's how we want it set up, and then to determine its validity, we have to think, could this statement be false? She might not be in the math club. She could just be a participant. So that's why it's invalid. Okay, the measure of the smallest angle in the right triangle below, the smallest angle. We know that 2x plus x plus 6 is going to equal 90 degrees. That means we have 3x's plus 6 equals 90. 3x, I'm subtracting 6, is going to equal 84. So if I divide 84 by 3, I get 28. So I have 2 times 28, which is going to be 56, and 28 plus 6 is going to be 34. So the smaller angle is 34 degrees. In the figure below, those are perpendicular. Angle 1 and angle 2 must therefore be complementary, because complementary means they add up to 90 degrees. And we already know that it's 90 degrees. The sum of 2 odd integers is even. Okay, so if I add an odd and then I add another odd, I'm going to get an even. If Eric is 13 years of age and Tim is 17, then, okay, we've got 2 odd integers. Their sum has to be even. The sum of their ages is even. Okay, that's just using facts. And given the information below, and we want inductive reasoning, every year in April the tulips bloom. The tulips bloom. If it is April, the tulips will bloom. If the tulips are blooming, then it must be April. Okay, we're going to forget about all the flowers because we don't want all of the flowers. But, okay, we can conclude that if it's April, then the tulips are going to bloom. Alright, and there we go.